Now, before we get started, let me go ahead and tell you what's going to happen. Well, that's not what I wanted to do. The next test will be on 6.1, 6.2, 7.1, and 7.2. I make it 4 sections. I don't do chapter 8 on this test. I move chapter 8 to the last test. Okay, so I want everybody to make sure you understand what I just said. The Unit 3 test is going to consist of those 4 sections. Now, I want everybody to write this down because I'm having some people that, 1, are not paying attention in class, 2, are not using the videos, and 3, coming to me with questions. I don't mean questions like math questions. I mean procedural questions. And I'm like, I've already covered that. You didn't listen. Okay? So I want you to write this down because I don't want you to come to me when I'm getting ready to give y'all a test and somebody go, well, what about 8.1 and 8.2? Well, I'm not going to reply to you because I've already covered it right here. Unit 4 is going to cover 8. There's only 1 or 2 sections, 9 and 10. That's Unit 4. Okay, so I'm just going to go ahead and tell you right now, and out of the material for Unit 3, 80% is going to come from 7.1 and 7.2. Okay, so I want to harp on 7.1 and 7.2 the next week. Okay, next week or 2 or whatever. Does anybody have any questions about Unit 3 and Unit 4? Okay. I'm glad everybody understands it. I just hope you don't come to me with a question saying that I didn't cover it or anyway. Y'all settle down. So now we're going into discrete probability. Discrete probability basically means we're going to use probability distributions. What is a probability distribution? A probability distribution, the way you go through these things, I'm not gonna go through this. I'm going to show you what a probability distribution is. Okay, well, let's go through discrete and continuous again. Discrete. What does discrete mean? Discrete means, can anybody give me the one word definition, starts with a C, for discrete? We talked about it in chapter 1 over and over. What is the one word definition for discrete?
Countable.
Thank you, sir. Who was that?
Brian Lee.
I can't see I got to click on you to see your name. Thank you, Mr. Lee. I appreciate it.
No problem.
Now, you know you're not supposed to talk. You know your student comrades are going to give you, you're not supposed to talk. Continuous. What is the one-word definition that starts with M for continuous?
Measurable.
Thank you, sir. Again, you must have drank your Mountain Dew this morning. Measurable. I'm just going to say measure. All right. So with discrete probability, we're going to be talking about numbers. With measurable, we'll be talking about probability that's measured in decimals, that's repeating. Okay, not repeating, sorry. Okay, so I just wanted to go over that right quick that we did back in chapter 1 and 2, so you don't forget. Okay? And that's what a discrete random variable is. A discrete random variable is one that's countable. Right there, countable. An example of discrete random variable would be something like households watching a TV show. Okay. The reason this is discrete, can you have 2.5 households? No. Okay. You can only have 0, 1, 2, 3, 4, 5, and let's say you surveyed 6 households. Okay. You can only have 0, 1, 2, 3. So anything having to do with households, with people, surveying people, households, that would be discrete. Discrete probability. What is the probability of 2 households? So you would just, what is the probability of greater than 2 households? Now this is where we get into the inequalities. You need to remember the inequalities. And you need to remember, hold on, I'm fixing to get a, what can you tell me is the difference between those 2 inequalities and these 2 inequalities? What's the difference? And Mr. Ryan, you don't answer because it's time for somebody else to answer.
The bottom 2 can be equal.
Okay, equals, exactly. Now, before I go to the next page, I want you to make a note of this. This is exclusive. And this is inclusive. Okay, inclusive means that you're including the number. Exclusive means that you're not including the number. Now, before we go on, I'm going to explain this because you've got some words that you're going to be using in this section that talk about exclusive and inclusive. And these are red, so that means you need to make a note. At least 2. Now, this is something that you might see in this homework. And we're going to use the example I used with households. Okay, so what does the slogan "at least 2" mean? I mean, what does it mean if you were explaining it to a 2nd grader or a 3rd grader? What does "at least 2" really mean in layman's terms?
You can have 2 or more.
2 or more, that's exactly what it means. 2 or more. So this is inclusive of 2. So that means that I can draw a closed circle here. And since I don't have decimals, I can't shade, but I can do this. So that means that I can include 2 and everything greater than 2. So where at least you would think that means low numbers, actually it means the numbers above 2. Okay? Then what does at most 3 mean?
You can have no more than 3.
That means at most 3. That means that's inclusive, isn't it? That means it's inclusive again. But is it more than 3? Or is it numbers less than or equal to 3?
Less than.
At most 3 means that your biggest number is 3. Therefore, 3 or less. So you would draw your and 6 and 7. Okay, and that would be 3, 2, 1, 0. Okay, now I know that some of y'all are going, well, I can't believe he's going over this stuff. Well, I'm going to tell you something. There's a lot of people that go through 12 years of high school or 12 years of school and didn't know this. Just like there's a lot of people that go through 12 years of school and can't read a ruler. Okay, so, and can't make change at a cash register. All right, so there are people that need this, so just chill. Now, the easier ones are the ones that go greater than 3. Now, somebody tell me what that is. That's pretty simple, but is it exclusive or is it inclusive? That means I want somebody to say something. Is greater than 3. Go ahead, Miss Cameron.
It's exclusive.
It's exclusive, exactly. This means pretty much greater than 3 means numbers greater than 3. So it means you cannot use 3. So this one would be 4, 5, and 6. And then, of course, the other one is less than 2. Again, this one's exclusive. And it would be 1 and 0. Okay, so before we even get started on this, you need to make sure you understand when you're given a mathematical sentence that looks like these two, you know that you've got inclusive, which means this one would be x is greater than or equal to 2. This one would be x is less than or equal to 3. I'm sorry, yeah, less than or equal to 3. So you need to be able to translate this into this or this. Now, I'm writing all this in red, and I can't stand to write in red, but this is important. If you don't understand this, you need to go over it. And this is exclusive, meaning x greater than 3 and x less than 2. Now, I'm going to show you one more thing, and it's very important that you understand what I'm fixing to show you. The complement is going to play a great deal in this section. And I need to check that because I always spell it, and then I don't know because there's an I and there's an E. And I got principal wrong in my other class because I thought Principal, P-A-L, was always the guy at school, but that's wrong. Principal also includes mathematics, and I didn't know that. Well, back a long time when I checked it. But we're going to check complement because complement is the same way. Sometimes the complement in math is spelled different. And I want to make sure I spell it right. There it is. It is E. Okay, good. All right. I thought it was. Now, what is complement? Well, we talked about this in chapter 1 or 2 or whatever, and it's what makes up the whole. Okay, some examples of whole. Some examples of complement. What's the complement of true? False. Thank you. What's the complement of 0? 1. What's the complement of yes? No. What's the complement of black? White. What's the complement of 0.35 to 1? What's the complement of 0.35 to 1? 0.65. If I tell you I have 1,200 workers, if I tell you I have 1,200 workers at a plant and 200 are sick, how many are not sick? 1,200 people work at a plant, and I tell you 200 are sick. How many are not sick?
1,000.
1,000.
Thank you. There are 1, 2, 3, 4, 5, 6 examples of complement. Now, I don't know how else to show you, what a complement is. It's always what makes up the whole. Whether you have a word, like true or false, like 0 or 1, yes or no, black or white, or if you're a total, the total here is 1, the total here is 1,200. The complement is what makes up the whole. You're going to be given a number, and you need to decide what makes up the whole. Now, why is this important in this section? Well, let me ask you, if I give you the households, and I like to show it on number line. And I ask you, what is the probability of at least 1? What is the probability of at least 1? So what does at least 1 mean? Well, we said at least 1, and I'm going to do this in a different color because it's important that you understand what I'm fixing to show you. All right. At least 1, that's going to clash. Let's do Superman colors. Let's do blue. I have to use a light blue because the dark blue is just about black when it shows up on this. At least one lavender. So if I wanted the probability of at least one, I would have to do the probability of 1 plus the probability of 2, probability of 3, plus the probability of 4, plus the probability of 5, plus the probability of 6. Does everybody understand that? A simple yes from 1 or 2 people would suffice.
Yes.
I appreciate it, Miss Cameron. Now, Miss Cameron, you know you're not supposed to talk in class, right? So your classmates are going to get irritated at you and Mr. Ryan because y'all are not supposed to talk. Y'all supposed to stay quiet. You know that, don't you? Oh, God, she took it seriously. She's not going to talk no more. Okay.
No, I will.
So anyway, what would the easiest way to do this problem? Instead of doing this, what could I do to make it a whole lot easier on myself? Well, the probability of all these numbers is equal to 1, right? Because I said in chapter 1 that the probability, or unit 1 in 1, 2, and 3, chapter 1, 2, and 3, somewhere in there, I said probability, or unit 2, sorry, the first part of unit 2, probability is a prediction from 0 to what? From 0 to 1. Did I not tell y'all that? Yes or no? And nobody says anything.
I think it was something along those lines. Yeah.
Thank you, Miss Cameron. I appreciate it. So any probability is going to be equal to 1 right here. Okay. So what would be the easiest thing to do here instead of doing the probability of 1 plus the probability of 2, blah, 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 blah? What would be the easiest thing to do?
Couldn't you just find the probability of 0?
There you go. And do what with the probability of 0?
Subtract it from 1.
There you go. I tell you what. So this is there's only one thing here. There's only one event here. So if I took 1 and subtracted the probability of 0, then that would give me what I'm asking for. So you've got to learn, and the best way to see this is with the number line. And that's why I show this number line more than the book does and more than other instructors do, because the only way to see it is with the number line. Okay? So 1 minus the probability of 0 is the same thing as at least 1. Let me do one more just so you'll see. Let's say I give you, I hate writing in red, but it's important. Now, I'm going to show y'all to draw a number line, and guess what? There's going to be about 5 of y'all that's not going to understand a damn thing I'm saying, and I'm going to ask you, did you draw a number line? And what are you going to say? No. So 3, 4, 5, and 6. Now, what if I give you the probability of at most 4? Well, the first thing you're going to do is you're going to graph it. Well, at most means that the biggest number is 4. And we are talking about the numbers less than or equal to 4 because we said at most 4 was inclusive from our previous notes. So that means 4, 3, 2, 1, and 0. Now I could do that. I could say equals probability of 0 plus probability of 1 plus probability of 2 plus probability of 3 plus probability of 4. Or what could I do? I could do the probability of less events and subtract it from 1. And right now, there we go. So 1 minus the probability of 5 plus the probability of 6. Now, it's very important that you understand that you can use the complement to actually make less work of the problem. And in this problem right here, this right here would be the complement. Of course, what tells you the complement? Well, when the problem asks you one of these 4 things, or something like one of these 4 things, then you should be able to find the complement. Now, that's what the slides are going to be talking about. They're going to be talking about at most, at least, greater than, less than. And they're going to give you a little chart that's going to talk about that. If I could find my handy dandy Excel spread. Oh, there it is. I was looking for Excel. Now, this is continuous. Continuous is when you include your fractions, decimals, and percents. So that's when this is what you're used to seeing in algebra, and you shade with a highlighter. That's when you include the fractions, decimals, and percents: 1/2, 1/3, 2/3, 7/8, 3/2, and those numbers that are in here. That's continuous. And of course, you see that here's an example. The number of light bulbs that burn out in a room. Well, that's not measured. That's discrete. The number of leaves. Notice the word number. And then it has the length. Length is measurement. So that's continuous. So there's 3 good examples. I would write those 3 examples down because you might see those on a standardized test, especially like a nursing test. What's it called? T's? Okay. A probability distribution. Probability distribution is going to look like this. Write it down. That's called a probability distribution. Well, here, why it says discrete, but you got decimals. Well, that's the probability. The discrete part is on the left side. So I'm going to write this down for you on a piece of paper so we can talk about it while you're writing it in your notes. Oh gosh, I got corona.
Bless you.
Thank you. And I'm going to shut down early because I'm going to talk about some stuff with y'all on pre-advising. I always do that with my students because some of them are a little bit confused. I always won't try to discourage you and confuse you as much as possible so you'll quit. So I'll talk about that. I think I talked about that with 109 and 111 the other day. I forgot. I left y'all out. So y'all can feel, bad about that. So I'm probably going to shut down. Let's see, y'all's class ends at 9:30. I'll probably shut down at 9 o'clock. And this is new material anyway, so y'all are still, some of y'all are still wondering what the hell I'm talking about with a reprieve. So I'll let y'all figure that out. But some of y'all that have figured it out about the reprieve, y'all can utilize this weekend a little bit more. And again, you're welcome. All right, so here is the probability distribution. I don't know why I use those slides. I guess to keep me in line. I'd rather write on paper. All right, there's probability distribution. Let me give you an example. The probability of kids. What's the probability of having 0 kids? What's the probability of having 1 kid? What's the probability of having 2 kids? What's the probability of having 3 kids? Probability, I don't see how anybody could have more than 2 kids. I can barely take 2. Whew. So some of y'all that come from 3, 4, 5 or more kids, your parents deserve anything you can give them because I can barely take 2. All right, so 3, 4, and 5 kids. So that's an example. Here is where you're counting. This is called the event. Okay? That's where the discrete comes in. So here, there you go. So what would be the probability of at least 3 kids? Well, you would do 3, 4, 5. So you would add 0.10 plus 0.03 plus 0.01. So what is the probability of at least 3 kids? Well, 10 cent plus 3 cent is 13 cent, 0.14. So you have a 14% chance of having at least 3 kids. I just did probability of at least 3 kids. Okay, so this is what I would ask you on a test. Number 1 on a test. What is the probability of having at least 3 kids? Boom. They'll give you this. Now, does the book do this? No. Does other teachers do this? No. Hubert does this because this is the way that Hubert learned it when he was studying how to teach mathematics. This is the way I pictured it. And that's why I'm doing it now, because it's easier to see when you're talking about this. Sometimes it's easier to see it, especially when you're talking about at most and at least. It's easier to see on a number line. What is the probability of having at least one? Well, probability of having at least one would be the probability of 0 subtracted from 1. The probability of 0 is 0.06. 1 minus 6 cents is equal to 0.94. So the probability of having one or more kids is 0.94. This is some of the questions you might get from whatever chapter we're on. I can't remember what chapter we're on. What is it, 6.1? Okay, this is 6.1 question. This is number 2. So these are 2 questions you might get on the test, given this thing right here. Now, remember the probability rules. Got my red marker. This is important. Each probability has to be between 0 and what? Each probability has to be between 0 and 1. And the summation of the probabilities have to equal what? 1. So you've got to check each one of these before you start. You can't have any negatives, and you can't have any numbers greater than 1. Okay, so you can't have a negative, and you can't have a number greater than 1. And when you add them up, they should equal 1. Now you need to check that, because sometimes on a test or a homework problem, they may throw a negative in there or a number like 1.58. And then the answer you should put is does not exist or cannot do this problem. If this doesn't equal 1, or you have a negative or a whole number in here besides 1, then you can't do the problem. It does not exist. And these are the type questions you'll get. Now, I'm going to actually show you, how to do this. Doesn't mean you have to do it, but I'm going to show you how we get this. And we'll get to there in just a minute. Well, in the future. So let's go back to, and there is the 2 rules. Write those down again in red or to highlight. The summation of all the probabilities should equal 1. And each probability should be a decimal between 0 and 1, including 0 and 1. So this one is not a probability distribution, because when you add up all these numbers, you get 0.97. These are 3 possible standardized test questions. Is the following a probability distribution? No, because these numbers add up to be 0.97. Now, I'm just giving y'all a second if you want to write that down, because I know, I've got how many people in here? 18 people. There's probably 3 of y'all that are writing this down, because you might see it on a standardized test. There's 3 of them. There's a no, and a yes. This one is no, because it doesn't equal 1. And these might be on the test too. I might put them on the test. Okay, here's another one. No, because you got a negative in there. You can't have a negative. What about adding them up? Well, if it has a negative, you don't need to add them up because it's not even, you don't even have to do it because it's not 1. So that's an example of not being 1 because of a negative. You don't have to write all those down. You can just put 0, 1, 2, 3, 4, 5, and then decimal, 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 and then a negative, and then put the negative and then highlight the negative. And that's, so you got example of not equaling 1, then you got a negative, and then of course the last one would be yes, because that's the only possible answer after you do 2 no's. So this one, if you add these up, they equal 1, and they're each one between 0 and 1. So there's 3 possible questions on a standardized test and 3 possible questions that are on my test. So I've shown you 2 or 3. I've shown you at least 5 questions now that could be on the test from 6.1. I don't get into graphing these, but you see that it's a little bit skewed right because the data, here's the center. The data is pretty much on the left-hand side, so it's skewed right. That's what happens when you graph these numbers. So you might want to be able to do that on your Excel spreadsheet or your calculator. Make sure you can graph it, or I just tell students, just look at it. It's low, and it goes up, and it comes down, and it levels out. So if the middle is right in here, y'all know that 2.5 is the middle. 2.5 right here. Then a lot of it's on the left side, so that'd be skewed right. Okay, write this down. How to find the mean of a discrete random variable, or how to find the mean of a discrete probability distribution. What do? Well, you multiply x times p of x and you add it up. You do exactly what the formula tells you to do. You take the event, you multiply it by the probability of the event, and then you add them all up. So you got to add another column. So I'm going to take my column right here, and I'm going to put it in an Excel spreadsheet. So handy dandy Excel spreadsheet. And I'm going to take the one we just did, x and p of x. Okay, so 1, 0, 1, 2, 3, 4, 5. And then 0.06, 0.58, 0.22, 0.10, 0.03, and 0.01. Okay, now I'm going to make this, I'm going to make it all centered because I have OCD about being centered. And I'm going to make this bold and underlined. And I'm going to make it all a little bit bigger. There we go. All right, everybody with me? Now remember, the formula says the summation, or the mean, is equal to, I don't know why it's blue, the summation of x times p of x. Okay, let me fix that. Okay, so read X bar, or to find the mean, that's going to be the summation, that's of X times P of X. So this is X and this is P of X. So we need to make another column. And what will it be called? It will be called X times P of X. And I'm going to color this, all this is going to be green. Because this is what we're given. P of X, I'll just do this in boxes. So this is what we're given. This is what we're given. And this is what we got to do. Equals 0 times 0.06, and copy that down. And then we're going to add that up, and we're going to call that the mean is equal to, and I'm going to add that up, summation of all those numbers. And you feel good about yourself. So the mean of this function, of this probability distribution, is 1.5. Okay? Technically, it's 1.5, which is rounded to 2. So this would be the mean. 2 events. So if this was children, the mean is 2 children based on 1.5. Because you have to treat the mean as a whole number because you're only dealing with whole numbers here. So you can't say the mean is 1.5 and then say you're going to have 1.5 children. No, you got to round it up to whichever one it fits between. And if you think about it, think about all the people you know that have kids. What's the average number of children that they have? Now, unless you're, live in a community with, that believes in having 15 kids, then that's different. But I can tell you right now, my family members, about all of them have 2 children. Okay. My uncle lives right up the road. He has 2 children. Now, my cousin, she has 3 children. But I can tell you right now, the last one was unexpected. Okay, they were going to have 2 children, and I think the last one was unexpected. My sister has 2 children. And if you think about it, that's, that could be possible if this was talking about children. I'm just using that as an example. When you find the mean, you're going to have to round it up or down to actually get that number right there, which is the mean based on this number. Okay. Now, if that was 1.3, then it would be 1. Since it's 1.5, I'm going to give it the benefit of the doubt and say 2 is your mean children. Now, we're going to find the standard deviation next. But we're going to go back to the slides. And I'm going to shut her down after that. There it is. I was wanting to get the standard deviation. There it is. Now I want to use, and we're going to shut her down after this. I'm going to highlight this one right here. That's the one I'm going to use. So make sure standard deviation is equal to the summation, the square root of the summation of x squared times p of x minus the mean squared. So go ahead and write that down, and we're going to stop there for the new material. We'll pick back up on that Monday or Tuesday. And we're going to talk about pre-advising. Okay. Now, let me shut this down and shut this down, and let me clear it and get this out of here. Now, what is pre-advising? Well, hold on just a second, and hopefully I can find. Well, I was going to find it. Give me just a second. Every semester, we go through pre-advising. What is pre-advising? That's when current students sign up, go by and see their advisor so they can sign up for classes and not, let classes fill up and they can't get into classes. That's one of the advantages of being a current student. Now, of course, there are students that don't take advantage of whatever is offered. There we go. Here's what I want to find. Okay. And the way that you see your advisor is you need to go through Starfish. And we had one student actually say, it's easier if you just go to the Learn tab, Blackboard, and go to Starfish. Now, you could do that, or you can go to the Connect tab, and I think it's under the Connect tab, and I think it says log into Starfish. And it will link you with your advisor's calendar. Okay, so I'll pull it up for you, and I'll show you what mine looks like. So let me go to Connect, and hopefully you're the Get Connected. I'm sorry, if Tri-County don't log you out, and click on Starfish Login. And of course, when you pull yours up, it will. I don't know what it looks like on y'all's end. I have to go to Appointments. And it should show, yep. Okay, so yesterday I had, or yesterday was, what's today? Thursday? So I've got 2 students that are, go away. I got 2 students that are signed up. Yesterday I had 1, 2, 3, 4 people signed up. Okay, so that's how you sign up. Now, your advisor calendar is linked to your Starfish. So when you log on to Starfish, you should know who your advisor is. Okay? I don't know how it works, but it does. Okay? Because these students have been able to sign up with me, so I know it works. All right? So that's that. Now, what do you need to do? Now, sign up for a time. Let me go back here. What if I get an email that says declined? Well, let me explain this to you. The reason that a teacher would decline, I've already declined like 3 students. This mechanism that we do this with is very rigid. Okay? You know how we block out these times? It's very rigid. I can't go in. If I've got a meeting at 2 o'clock on Friday, I can't block it out with these. It laps over my meeting. So you have to tell students, like I told my students, do not sign up for the 15th because I emailed my advisees. I said, because the 15th, I've got a meeting at 2 o'clock to 5 o'clock. Okay, it's training. So I told students not to sign up for the 15th. Okay, so if a student does sign up and they didn't read my email, I will decline it. Now, why am I telling you this? Because if your teacher declines it, that's because they probably have a meeting or something that they could not filter out with the Starfish calendar. Do y'all understand what I'm talking about? In other words, it's overlapping their meeting. So if they decline, it doesn't mean they don't like you. It doesn't mean they don't want to do their job. It just means that the calendar is overlapped their meeting. Okay, so that's why they can't do it. Most of the time, you're going to get an accept email. I know I send back an accept email when students get a appointment with me. Now, as far as math goes, y'all are in Math 120. So a lot of you are either a nursing student or a art student, like you're going to teach history or you're going to teach, psychology, or, you're going into the arts. Okay, so you're going to take Math 120 and Math 103 pretty much. So you would go to your teacher and say, I took Math 120 and I'm doing good in Hubert's class, and I need to sign up for Math 103 because I need 2 science and 2 maths because I'm an arts major. Okay. Most people, I tell most of my advisees to take these 2 maths. Some nursing students need to take the 120, and some are asked to take the 110, especially radiology, So you need to check with your individual advisor or your catalog for where you're transferring. Okay. Other than arts, you're either business ag, which means you're doing the 130, 230 business calculus route, or you're in engineering and sciences, which means you're going the engineering calc route. So, and you would talk to your advisor about English and what you're going to take next semester, and they unlock your registration so you can go in and register on the 19th. The 19th is when you register for classes. 19th. October 19th. That's when it opens up. So you need to get this done. You need to sign up and, get to your advisor. Now, who's got questions on anything course-wise, anything? You got questions about degrees, anything? Because I always have students with questions because they don't know. And most of y'all are new students and you don't know. So ask away. Anything about the pre-advising process, signing up, or anything about classes? Anybody got a question? What a surprise. Nobody's going to ask a question in here. Well, that's what I figured. Okay. So nobody has any questions. It'll be the first class in history that nobody has a question on at pre-advising. Everybody's up on it. Okay. All right. I've got to write this class down. This is the smartest class I've ever had. They never say anything and they don't have questions. Maybe we ought to get y'all to teach. Any questions? All right. Well, nobody has any questions. Now, for those of you that understand what the reprieve is and the lost ones in the class don't have a clue, somebody explain what the reprieve is that I have given y'all. Somebody. Miss Scarborough, are you still here? Miss Scarborough still here?
Yes, sir.
What is the reprieve?
You change the homework and test date to Monday.
Exactly. And I guarantee you there's somebody in here that had no clue. People, y'all have got to start using MyLabs Plus. And if you've got a question, you got to actually go in there and look. Okay, just like sending questions. And I guarantee you there's somebody in here that didn't know that. So you got a reprieve. I'm letting y'all, since I'm bringing in new material on on Friday, I decided, or Tuesday, in your case, Thursday, I decided to open up your math and homework, your homework and test till Monday, because technically I'm just starting new material today. So those of you that want to retake the tests for the second and third time and improve your grade, you got time to do it. Those of you that want to do some more homework problems to improve your homework grade, you've got all weekend to do it. Okay? You're welcome. Yeah, you're welcome. All right.
Appreciate it.
Anyway, yes,
Thank
you're
you,
welcome.
Mr. Good.
Thank
Yes, you got a question? Anybody got a question? All right, y'all have a good weekend, and I will see y'all Tuesday. If you have done everything and you don't want it, then go ahead and look up 6.1 and go ahead and be reading it and go ahead and be looking at some of the problems. You don't have to do them, just look at them. And I'll see y'all Tuesday, and have a good weekend. Yeah. Oh, I forgot to take the roll. Shoot. Hold on a minute. Oh, people are leaving. Okay. That's all right. Go ahead. I knew I forgot something.